Shake Table Lab by Cooper Say and Ethan Farah. We decided to create a plan before we began to build, so we drew building blueprints for our Shake Table tower. The sketches show the measurements and designs we planned to include in our tower. Cooper and I planned for the first floor of our structure to be 20 centimeters tall, 20.5 centimeters wide at the base, and 17 centimeters wide at the top. For the second floor, it measured 17 centimeters at the base, 14 centimeters at the top, and 17 centimeters tall. In total, our tower would be 37 centimeters tall. Our first and most important period of construction was for the fundamental building blocks of our tower, including building a frame, adding double supports as legs, and building a sturdy base. We did this by using iron bolts or straws poking through the floor of our tower to keep it from bouncing. During the second construction period, we were able to allow the support of crossbeams to make our structure sturdy. Crossbeams are made up of two straws placed perpendicular to each other, then rotated to fit in the spaces between the frame. Cooper and I need one of these arrangements for each of the square spaces on the sides of the tower. These additions help to strengthen the sides of the build, which were weaker than other portions of the tower. The third stage of our building process included adding floors and floor supports. We made the floors out of yellow construction paper and also crossbeams underneath the paper to hold up the sandbags. Another measure we added was to include supports reaching up from the floor beneath. Our completed tower is what stands before you. It has a pendulum at the top to counteract the swinging of the tower, and also a simply extravagant and majestic roof with art that is exquisite. Construction sketches are what show the measurements of the built tower, since the measurements are going to be different than the original plan. The measurements include the height, length, and depth of the tower, and the size of the roof. The first story of our tower was 20 by 20 by 20.5 centimeters. The second story was 16 by 16 by 18 centimeters. Underneath the roof of our tower, the floor that held it up was 15.5 by 15.5 by 11 centimeters, with the roof being 28 centimeters tall. Our building resulted in a total height of 84.5 centimeters. The static test of our tower was when Cooper and I placed the sandbags, which will be used on the moving test, onto the second and third floors of our tower. Our tower held them steadily without showing any signs of weakness. We decided to strengthen these indicated parts of our tower, since Cooper and I knew that these are the assets that held up most of the tower. If they were not strong, they would lead to the downfall of the tower. Our tower has many strong segments to it. The top three of those are the central column that helps to hold up the floors, the cross supports surrounding our tower, and the doubled-up legs which act as corner edges. The top edge is one of the weakest parts in our tower, since it is a single straw in each of the four corners, helping to hold up the weight of a beautiful roof and 4 ball bearings. Having the single straws as corners can lead to the top of our tower collapsing. Cooper and I have placed much tape on our build to keep the straws in place and to help strengthen our tower. The tape is an efficient way to bind the straws together, since it can easily be cut and bent in any which way. We decided that having only straws as the floors was not strong enough to hold up the weight of the sandbags, so we added construction paper. The floors made of yellow construction paper both fill in the gaps between the straws and strengthen the platforms. This video showcases the first ever moving test of our tower. It held 4 sandbags and seemed pretty steady.
This is for the first little... They have a counterweight in their tower.
The final test of our tower led to its complete and utter destruction. It held a total of 14 sandbags, and on the 16th, it collapsed. No! During the shaking of our tower, a sensor was attached. This sensor showed the X, Y, and Z movements of the tower. The X-axis is the left and right movement of the tower, the Y-axis is the forward and back motion, and the Z-axis is the up and down motion. The blue graph is the Z-axis, the yellow is the Y-axis, and the green is the X-axis. Although the width of the graphs look the same, the true width of each graph is different. The X-line span is the greatest, then the Y-line, and finally the Z-line. This is true because the tower was moving mostly side to side, very little up and down, and very little forward and back. Our tower supported the weight of 14 250-gram weights, evenly spread out on the first and second floors. At 16 sandbags, our tower could not stand. It collapsed in complete mayhem and chaotic destruction. The Illuminati tower failed at midpoints of the ground supports and at the central pole. Although we had strengthened these parts, the weight of 16 sandbags was too much. This led to the tower's utter destruction. Also, the pendulum that we attempted to build at the top did not sway correctly against the swing of the tower. So instead, it swung with it and led to swaying the tower off balance. The most important changes that we could have made to this tower was to make it bend in farther, and also to add one more straw to each crossbeam. By making the tower lean in farther, we would make the weight be more evenly spread out and more absorbed. By adding one more straw to the X supports, I would help by adding more triangles, since triangles are the strongest of all polygons. By having one X and adding one more straw going straight down, that would give us 6 triangles versus 4. I learned that to create a sturdy building that would be earthquake-proof, you have to only take into account not the materials used, but the arrangement of those materials. For example, I learned that cross supports in the shape of an X are much stronger than cross supports in the shape of a V, because X's give you 4 triangles versus V's giving you 3. Also, I learned that to use as many triangles as possible, since that is what would help the building be sturdy. I enjoyed literally everything about this project. My favorite part of this project was definitely building with my partner Cooper. I also enjoyed building our roof and pendulum. I could express my creativity and also do something out of the box with my partner. And this was one of my best experiences in 6th grade science class.
My building held 14 sandbags. It failed at the bottom story because the pendulum we put at the top of the tower to keep it steady actually made the building top-heavy and sway too much, which caused our bottom supports to collapse. If I redid this project, I would take out the pendulum and make our building structure come in more to make a sturdy base that would hopefully support our building entirely. I learned that if you are building an earthquake-proof building, you want to put as many triangle supports on the bottom foundations as possible. Refrain from making your building too tall, and make sure that it has a wide, steady base. What I enjoyed about the Shake Table Lab was working with my friend Ethan and being given the opportunity to create something that was creative and imaginative, but that would still go to use. The Shake Table Lab was a great experience for me.